Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today I'll be interviewing Patrick Darmawi-Iskandar, who is working on his Ph.D. from MIT and holds a bachelor's from Vanderbilt. How are you doing today?
I'm good. How are you?
Good. So to get started, I wanted to ask what you're involved in high school and when you decided on choosing your degree for your bachelor's.
Yeah. So in high school, I think I did a lot of sports, but I also liked working on my own personal projects. So I was very fortunate to go to a high school that had a lot of opportunities in STEM. And in particular, they taught us how to make circuits, how to do woodworking, metalworking, laser cutting, et cetera, et cetera. And through that, I really fell in love with making my own projects. And so in particular, obviously I'm an electrical engineer now, so I really enjoyed the circuits classes in high school. And I love doing using like Arduino kits and stuff to kind of solve everyday problems I had around me.
Yeah. And yeah, so when did you kind of come up with electrical engineering then? Was it through that class?
Yeah, exactly. So I think I always knew that I wanted to do some sort of STEM. I found out I didn't really like biology in undergrad, or sorry, in high school. Um, and I enjoyed things like chemistry and physics. But I knew I think I probably wanted to be an engineer. And so I was going through all the different types of engineering. There's mechanical engineering. I think I found that I didn't like physics one as much. And then, biomedical engineering, I wasn't good at bio, so that wasn't going to cut it. And then there's like chemical engineering, but that's like, I didn't find that interesting. And so I really just settled on electrical engineering. I think I found that I really enjoyed um, being able to make things with circuits. I thought it was really cool. Um, how they worked and kind of the versatility of circuits. I also enjoyed that you had a little bit of coding and you had a little bit of physics and a little bit of chemistry, and electrical engineering kind of encompasses a lot of different fields. And so that's kind of how I settled on it.
Yeah. So what was your experience like while at Vanderbilt?
Yeah, at Vanderbilt, I tried my best to participate in a lot of clubs and really put myself out there. Um, I think it was a really good school. It doesn't have a super big engineering program, but surprisingly has a very strong research, like a very strong graduate school in a very niche field, which is the effects of radiation on microelectronics. Um, and I could explain a little bit about what that is. So basically, in space and in certain applications such as biomedical or nuclear, there's a lot of radiation, whether that comes from outer space or the tools that you're working on. Obviously, in a defense environment, there's nuclear considerations and whatnot. And it turns out that this radiation, as well as being really bad for humans, is also really bad for electronics. Um, and so when you think about sending, a rocket into space or sending a satellite into space, and that satellite, that's not something that you could repair, right? You can't easily go up there. So that thing has to be robust. Um, you want it to be highly reliable. And so this radiation is actually a very, very big concern because it greatly degrades the electronics. And so that was like kind of the main thing I did in undergrad was doing research on that.
Mhm. Yeah. So I saw your valedictorian. What do you think contributed to having such good grades?
Yeah, I mean, it really comes down to studying hard, but also studying smart. Because I think there are a lot of people in undergrad who, I mean, I did work hard, but there are a lot of people who probably worked harder than me. But I think the key thing that I understood, um, coming from my high school was like pretty competitive too, and so I had to learn how to do well there. Was understanding your learning style and understanding the types of mistakes that you make. And so, uh, for example, I knew that I was fairly good at like grasping concepts pretty early, but I always struggled to not make mistakes. So my problem on tests was consistency. And so in order to kind of hone my consistency, I would do a lot of practice problems. I would always keep track of the mistakes that I made. Um, and I would keep them in this list. And before the test, I would always make sure I know like what type of mistakes were common for me so that when I would go through the test, that I looked out for those. And so I think that's a key component is understanding your weaknesses and trying to work against those. You know, some people maybe they struggle more with the speed aspect, and so they should like hammer problems with like a time crunch, for example. And then when it came to being valedictorian, it really comes down to if you want to have like the best grades possible, being consistent. Um, I don't, I think I would caution against caring too much about grades. Personally, I know that sounds very hypocritical coming from me, but I think at least at Vanderbilt, a lot of your classes, they came down to testing when it came down to grades, right? So actually what it comes down to is becoming very good at taking tests and understanding the types of problems that your professors are going to give you, and how to answer the problems in a good way. Um, but grades doesn't necessarily like correlate with understanding, in my opinion. And so I became very good at being like very good at test taking and stuff like that, but I don't think it necessarily contributes to your understanding. And at the end of the day, what really matters is how well you know the material, not really your grades. And so I would personally caution against worrying too much about grades. Not that it doesn't matter, but
Yeah. So when did you make the decision that you wanted to get a PhD?
yeah, I think I made the decision around my sophomore year. Um, I think I really liked electrical engineering, but unfortunately, like an undergrad curriculum is usually pretty broad. Electrical engineering is a very, very broad field. Like there's so many classes and so many different subfields. And when you take these classes, you learn a lot, but you really only learn the basics. And it's really hard to do anything with just the basics. And so that's when I decided I really wanted to specialize. And that's also around the same time I started doing research. Um, and so in order to want to do a PhD, you want to you have to want to learn and then also want to do research because it's just mostly research. So that's kind of what I wanted to I decided to do a PhD.
Yeah. And what was the process like while applying to schools for that?
Yeah, yeah. So applying to grad school is similar in a couple ways to undergrad and also a little bit different. It's similar in that you basically like write a few essays or usually only one essay. You need letters of recommendation and you apply through a portal. It's like pretty similar to undergrad in that way. It's a little different in that what they care about is a lot different. Um, for undergrad classes, I think they like care a lot more about having a very you know, holistic view of the applicant, which is true for grad school. But for for grad school, they really, really care about your research in undergrad and being an effective researcher when you become a PhD student. Because if you think about for grad school, I am a PhD student, but it's really more like a job than anything else. They're basically paying me to do research and output good research results. And kind of learning and taking classes is like almost it's not secondary, but it's not like the main role I have. And so for grad school applications, they care a lot more about can you think about your research? Can you think about the state of the field? Can you think creatively? Um, do you understand the field? Do you understand what it's like to do research and how to do good research? Whereas I think in undergrad, it's a lot more holistic about some of your other extracurriculars and grades and whatnot.
Yeah. So when it came down to picking the school, obviously MIT is MIT, but what stood out to you when you were looking at schools?
Yeah, yeah. So, I mean, obviously, MIT is a great school, but when it comes to grad school, you'll find that just because it's a good name brand school doesn't necessarily mean they one have the research that you do that you want to do, or two they're good at the research that you want to do. And so it turns out, luckily in my field, like the research that I want to do, they have here, and MIT is good at it, but it's not necessarily true. And so I would also caution against choosing the grad program that you go to based on the name brand of the school, because what ultimately matters is your PI, is one, your PI, and then two, like the type of research that you're doing, because you want it to align with what you're doing. But I was very fortunate in that MIT did have the research that I want to do. And then on top of that, MIT has a lot of very advanced facilities that make doing the research I do much easier. So for example, I do semiconductor research, and we have a clean room here called MIT Nano, which is probably the most like advanced academic clean room in the world. And so that was a huge reason for me to want to come here because I knew that if I wanted to do really advanced semiconductor research, I needed to have the best tools possible and the best resources possible, and MIT offered that to me.
Yeah. So for MIT, do you pick your PI and the lab you're going to work in before or after you get accepted to school?
Um, you officially pick afterwards, but when you're applying to any graduate school, you should definitely at least have in mind what PIs you want to work for. Um, and that should be written in your application. And because of that, it'll probably be filtered to them. Like your prospective PIs will probably have some idea of which incoming students they might have. And so in that way, like you are kind of not exactly picking, but you are kind of narrowing down what PIs you'll be wanting to work for in the graduate school application process.
Yeah. So right now, do you know what your future holds at all after you finish your PhD?
Yeah, no, that's a great question. I don't know. I think I'm unlikely to go into academia, but I will probably go into industry, either semiconductor industry or the tech industry. Um, Hopefully with some sort of research role, because I really do enjoy research, and that's why I did end up doing a PhD. Um, but yeah, it's unclear exactly where I'll end up, but it'll probably be some sort of company.
Yeah. So do you have one piece of advice for someone who's still in high school or early in college wanting to follow a similar career path as you?
Yeah, I think my main piece of advice is that you should do personal projects. And what I mean by that is you take all these concepts that you're being taught to you in classes and in your labs, and you apply them for yourselves in your own project. Because I think classes, at least at Vanderbilt, we were taught a lot of theory, which is obviously very, very useful, and you should know the theory very well. But then if you don't actually go out there and apply it, it's very hard to kind of connect it to the real world. And on top of that, it really, if you do personal projects, it really um, boosts your resume a lot and boosts your interviewing a lot as well because you're able to say, hey, like look what I did. I don't just have good grades. I'm able to actually apply this to the real world, which is much more of what engineering is like, right? It's not like you're taking exams. You're actually taking these theories and these concepts and you're using them to make something. And so if your hiring manager can look at you and see that, oh, like this person knows how to take these concepts and actually do something with them. I think that's really, really important. And from all the feedback that I've gotten from my like previous hiring management managers at like internships I've done and stuff like that, they've said that like that's the key thing that stands out for them, not just on my application, but on other people's applications is, grades matter, but like not that much. But like, do they do they have a passion for electrical engineering and can they apply it from outside the classroom?
Yeah. So thank you for joining me on the podcast today.
Yeah,
Um,
no, thank you for having me.
yeah, no, that's super informative.